Good morning, students. Welcome to Computer Organization class. This is Veena A. Patil from Department of CSE BLE CET Vijaypur. In the previous video, we have studied about the parallel interface and serial interface. And today we are going to learn about the PCI bus, which is nothing but peripheral component interconnect bus, which we call as PCI bus. Now, PCI bus supports the functions in a standard format independent of any processor. So, it has a standardized format which it can use independent of any processor. Device connected to PCI bus appears to the processor as if they were connected directly to the processor bus itself. They are assigned addresses in the memory address space of the processor. The PCI bus was introduced in 1992 and the bus was developed to cater to the growing demand for faster and large bandwidth bus to connect high-speed disk and graphic devices. It is a low-cost 32 to 64-bit bus having plug-and-play feature for connecting input-output devices. To connect a new device, the user simply has to connect the device interface board to the bus. The software will take care of the operation, and PCI bus is defined for operations with either 5 volts or 3.3 volt power supply. Either 5 volts or 3.3 volts power supply. Now, let us see how data transfer takes place using PCI bus. Today's processor, they include a cache memory on chip, and data are transferred between the cache and the main memory in burst or several words. The words are usually stored at successive memory locations. When the processor specifies an address and requests a read operation from the main memory, the memory responds by sending a sequence of data words starting at that address. For a write operation, processor sends a memory address followed by a sequence of data words to be written into successive memory locations starting at that address. The PCI bus is basically designed to support this burst mode of operation. So, you have to remember this. The PCI bus, it supports 3 independent address spaces, that is memory, input output and configuration. The input output address space is used with the processor, say like Pentium, that supports a separate input output address space. The configuration space is intended to give the PCI its plug and play capability. A 4-bit command that accompanies the address identifies which of the 3 spaces is being used in a given data transfer operation. We assume that the master maintains the address information on the bus until data transfer is completed, but the address is needed only long enough for the slave to be selected. Thus, the address is needed on the bus for 1 clock cycle only, freezing the address lines to be used for sending data in subsequent clock cycles. Now, the result is a significant cost reduction as we don't have bigger memory storage needed. A master is called an initiator in PCI terminology. The address device that responds to ready and write command is called as a target. Now, let us have a look on the data frame signals on the PCI bus which are being used. So, in this table I have given here, as you can see here, the clock, it is a function is, it is to generate a frequency of 33 megahertz to 66 megahertz clock. Then we have a frame which is sent by the initiator to indicate the duration of a transaction. AD, it is a 32 address or data line which may be optionally increased to 64. C or BE hash, it is a 4-bit command or byte enable line. It can be 8 for a 64-bit bus. Then IRDY hash or TRDY hash indicates initiator ready and target ready signals. And div SCL hash, it is a response from the device indicating that it has recognized its address and is ready for a data transfer transaction. ID SCL hash indicates initialization device select. Now a signal whose name ends with the symbol hash is asserted when in the low voltage state. Now let's try to understand. So this is a diagram to show you how PCI bus is connected. I think in the last video we have already seen, but still then I will show you. Yeah, this is what we had seen. We had seen that there will be a bridge. This is the PCI bus. So bridge is between the processor bus and the PCI bus. This bridge circuit translates signal and protocols from processor bus to PCI bus. So to PCI bus there are additional memories, SCSI controller, Ethernet, USB, ISA. We have learnt it in previous video. So this is the diagram for showing the PCI slot. So this is how it will be connected diagrammatically if you see here. So let's see using timing diagram how a read operation on the PCI bus is going to take place. Now the functioning of PCI bus is same as that of a multiple bus architecture. In clock cycle 1, that is the first clock cycle, here the processor, it asserts frame hash which indicates that the beginning of a transaction, and address on the address lines, and ready on the C or BE hash lines. That is this frame hash signal is to indicate the beginning of a transaction. It also sends the address on the address line, that is AD lines, and a command on the C or BE hash lines. The command is in this case that is to read, indicating a read operation. In clock cycle 2, the processor removes the address and disconnects its drivers from the AD line. The selected target enables its driver on the AD lines and fetches the requested data. It also asserts div select DEV SCL hash low, and it keeps it at that level until the end of bus transaction. The data is placed on the bus during clock cycle 3. You can see here at this point it is indicating by making it low, and here we have seen that frame and AD address will be put in the first, as well as you can see in the first clock cycle C command or bus enable signal or line are used to send a bus command in the first clock cycle. For the rest of the cycle, each of these 4 lines is associated with 1 byte of data on the AD lines. The initiator, it sets one or more of the command or bus enable line to indicate which this is not bus enable, byte enable, to indicate which byte line are to be used for transferring data. If the target is capable of transferring 32 bits at a time, all 4 C bar BE hash lines are asserted. The initiator, it asserts the IR dy signal low. You can see here it does it low. IR dy, it stands for initiator ready, so it makes it low during clock cycle 3 to indicate that it is ready to receive data. If the data is ready, the target will make its target ready, this line, target ready signal low, and sends a word of data. The initiator loads the data into its input buffer at the end of the clock cycle. Next, 3 bytes of the data are sent by the target during clock cycles 4, 5 and 6. So, once the first bit is put, the consecutive byte is put, the consecutive bytes of data will be automatically sent on the line. A frame hash signal is used to indicate the duration of the burst. It is deactivated during the read or writing of second last word. So you can see here it is deactivated during the second last word of the transfer. Now in this figure, during clock cycle 5, I have shown here clock cycle 5, while reading the third word, it is indicated. Now after sending the fourth word in clock cycle 6, the target disconnects its drivers and negates its div select, that is initiation device select line. At the beginning of clock cycle 7. So this illustrates the effect of IRD, that is initiator device select and target ready signals. Now coming to device configuration, PCI device configuration. Now when an input-output device is connected to a computer, several actions are required to configure both the device and the software that work on the devices. Once the device is connected, the software needs to know the address of the devices. The PCI, it includes a small configuration ROM memory in each input-output device interface that stores information about that device. The configuration ROMs of all devices are accessible on the configuration address space. The PCI initialization software reads these ROMs whenever the system is powered up or reset. It checks whether the device is a keyboard, printer, disk controller, and so on. The devices are assigned addresses during the initialization process. So during configuration operation, devices cannot be accessed since they have not been given the address. Therefore, each device has an input signal called initialization device select, which we had written as IDL SEL, initialization device select hash. Now, during a configuration operation, instead of device address, ideal SEL hash is used to select the device. The motherboard has the ideal SEL pin of each device connected to one of the upper 21 address lines like AD11 to AD31. So thus a device can be selected for a configuration operation by issuing a configuration command and an address in which the corresponding AD line is set to 1 and the remaining 20 lines is set to 0. The lower address lines AD10 to AD0 are used to specify the type of operation and to access the contents of the device configuration ROM. The maximum number of input-output device that can be connected in this way is limited to 21 devices. So the configuration software scans all 21 locations in configuration address space to identify which are present. The device is assigned an address by writing that address into the appropriate device register. The configuration software also determines device interrupt priority. The PCI bus has 4 interrupt request lines. The software tells that the device which of these lines it can use to request an interrupt. Now all this process is done internally without any intervention from the user. The user simply has to plug in the interface board and power on the system. The software configures the device and makes it ready to use. If a device requires initialization, the initialization code is stored in a ROM, different from configuration ROM in the device interface. The PCI software reads this code and executes it to perform the required initialization. As I have told earlier also, PCI bus has or it operates either for 5 or 3.5 volt power supply. SCSI bus. The acronym SCSI stands for Small Computer System Interface. It is a ANSI, that is American National Standard Institute, X 3.131 standard. It has a standard X 3.131. SCSI is a set of parallel interface standard for attaching printer, disk, CDs, DVDs, drives, scanner and other peripherals to computer. In the original specifications, devices such as disks are connected to a computer via a 50 wire cable up to 25 meters in length with a data transmission rate of about 5 megabytes, or you can call it as 5 Mbps. In modern computer, this SCSI is replaced by SATA. SATA stands for SATA. It stands for Serial Advanced Technology Attachment. A SCSI bus may have 8 or 16 data lines. The bus may use a single-ended transmission where each signal uses one wire with a common ground written for all signals. Another option is to use differential signaling where a separate written wire is provided for each signal. Now if 5 volts is used, it is called high voltage differential signaling or HVDS, and the 3.3 volt version is known as a low voltage differential signaling or LVDS. The SCSI has a standard The SCSI bus standard has been revised many times, and accordingly it is named as SCSI 2, SCSI 3 format, and now the presently available is SCSI 3. Because of the various options, the SCSI connector may have up to 50, 68 or 80 pins. So the maximum transfer rate ranges from 5 Mbps to 320 Mbps. So to maximize data transfer, the bus length is limited to 1.6 meters for single ended transmission and 12 meters for LVDS. The maximum capacity of the bus is 8 devices for a narrow bus and 16 devices for a wide bus. The SCSI bus is connected to processor through a SCSI connector. So you can see here first how it is connected. We have here a hard disk, we have ROMs, scanners. This is SCSI adapter. So in actual it will look like this, SCSI hardware. Okay. So internal terminals. Now the SCSI bus is connected to the processor bus through a SCSI controller, which I think we had seen previously. You can see here it is a controller. This is a SCSI bus. It is connected through the controller. Now this controller uses a DMA scheme to transfer data packets from main memory to the device and vice versa. A packet may contain a block of data command from the processor to the device or status information about the device. Each device is connected through a controller which implements the communication protocol needed to transfer information over the bus. There are two types of controller connected to a SCSI bus, initiator and target. An initiator will select a particular target and sends command specifying the operation to be performed. The SCSI controller acts as initiator and the disk controller operates as a target. The initiator establishes a logical connection with the target, and after this the connection can be suspended and restored as needed to transfer commands and data. When a particular connection is suspended, other devices can use the bus to transfer information. And this overlapped data transfer is a key feature of the SCSI bus, which leads to better performance. The other interesting feature of the SCSI bus is that data transfer are always controlled by the target controller. To send a command to a target, an initiator requests control of the bus and after arbitration selects the controller it wants to communicate with and gives control to the bus to the target controller. Then the controller starts a data transfer operation to receive a command from the initiator. Now this is the diagram of standard input-output interface, which we have already seen earlier also. So SCSI bus, it acts as a SCSI bus controller, it acts as a bridge circuit that translates signals and protocols from processor bus to SCSI bus. So this is the extension bus on the motherboard. So PCI bus is the extension bus. Now here you can see to the SCSI controller we have SCSI bus to which different devices, CD-ROMs and other things are connected, which I think I had shown here already in the diagram. Yeah, here we have seen earlier. So the internal part also we have seen. Now let us see one example. We'll consider an example of a disk read operation. The processor has to read a block of data from disk drive, and the data are stored in two non-contiguous disk sectors. These are the assumptions. The processor sends a command to the SCSI controller, then the following sequence of events will take place. Now let's see what are those. First is the SCSI controller acting as an initiator. It contends for control of the bus. That is, stakes claim for control of the bus. When the initiator wins the arbitration process, it selects the target controller and hands over control of the bus to it. The target starts an output operation, that is from initiator to target. In response to this, the initiator it will send a command specifying the intended read operation. The target now has to perform a disk seek operation, hence it temporarily suspends the connection from the initiator and releases the bus. The target controller sends a command to the disk drive to move the read head to the first sector involved in the read operation. Then it reads the data stored in that sector and stores it in a data buffer. I would like to show it through a diagram. So usually this will be the disk, which will be divided into sectors. These are called as sectors, and inside sectors we have tracks. Okay, so it looks almost like a spider web. So I would like to draw it more properly here. This is the disk, which is divided into sectors, and inside this we have tracks. Okay, and whenever a read write has to be done, if this is the read write head, so this read write head has to be brought to particular sector. These are the sectors. So it has to be brought to the particular sector first. Then in that particular sector, from which track the data is needed, to that particular track this read write head has to be taken. Okay. So the target controller sends a command to the disk drive to move the read head to the first sector involved in the read operation. Then it reads the data stored in this in that sector and stores it in a data buffer. So the first sector is reached, and then it reads the data and stores it in the data buffer. Now the target requests for control of the bus. After it wins arbitration, it reselects the initiator and restores the suspended connection. The target transfers the content of data buffer to the initiator and then suspends the connection again. Now the data transfer is done in parallel over 8 or 16 lines of buses. Now the target controller it sends a command to the disk drive to perform another seek operation. Then it transfers the content of second disk sector to the initiator to describe to the initiator as described earlier. At the end of this transfer, the logical connection between the two controllers is terminated. As the initiator receives the data, it stores them into the main memory using DMA technique. The SCSI controller, it sends an interrupt to the processor to perform the processor to inform the processor that the requested operation has been completed. The SCSI bus standard, it defines a wide range of control message that can be exchanged between the controller to handle different types of input-output devices. Now coming to bus signals. Now let's see what are SCSI bus signals and how arbitration selection is being done. Now the bus signals are shown in the table here. Now all signal names are preceded by a minus, you can see here a minus sign to indicate that they are active low. Address lines are not present. Data lines are used to identify the bus controller involved in data transfer. Now a narrow bus of 8 data lines will have 8 controllers, whereas a wide bus can accommodate up to 16 controllers. Now each controller is associated with a data line that has the same number. A controller places its own address or the address of another controller on the bus by activating the corresponding data line. Thus, it is possible to have more than one address on the bus at the same time. Once a connection is established between two controllers, further addressing is not required and data lines are used to carry data. The main phase involved on the operation of SCSI bus are arbitration, selection, information transfer and reselection. So we shall see that here. So before that, let's see these bus signals. So handshake signals are minus REQ. It stands for request, that is asserted by the target to request a data transfer cycle. Acknowledge, it is asserted by initiator when it has completed a data transfer operation. Similarly, the direction of transfer, whether it is a read or write, so input or output, so it is asserted to indicate an input operation related to the initiator. Now other signals like minus ATN, it is attention, it is asserted by initiator when it wishes to send a message to the target. Similarly, reset, it causes all devices to disconnect from the bus and assume their startup state. We have some more here which I had missed. Data. Now in data types we have DB0 up to DB7. So this is nothing but data lines from 0 to 7. So these lines carry 1 byte of information during the information transfer phase, and they identify device during arbitration selection and reselection phases. The DBP, it is a parity bit for the data bus. Now in phases we have different signals like busy, select. Busy, it is asserted when the bus is not free, and selection, it is asserted during selection and reselection. This information type of signals are like minus control bar data. It is asserted during data transfer of control information like command or status or messages. And MST, it stands for message. indicating that the information being transferred is a message. So these are some of the signals, bus signals like data, phase, information type, handshake signals, direction of transfer, and other. Let's have a look on main phases involved in SCSI bus. So we have here arbitration, selection, information transfer, and reselection. Before that, let's have a look on the timing diagram. Now this diagram, it illustrates arbitration and selection on the SCSI bus. The bus is free when the bus busy signal is inactive. As I told you, this is with bar. So with bar means it is active when it is low. So it is inactive when it is high. Okay. So bus signal is inactive when it is in high state. So a controller it requests the bus by asserting the bus busy signal and by asserting its associated data lines to identify themselves. The SCSI bus uses a distributed arbitration scheme for bus arbitration, and here you can see controller 2 and 6 request the use of the bus simultaneously. So that you can see by their signal, if their signal goes low here and here up to here. Okay. So that is the indication for requests. Now each controller has a fixed priority with controller 7 having highest priority. So when bus busy becomes active, that is it becomes from high to low. When it becomes active, all controllers that are requesting the bus examine the data lines and determine whether a high priority device is requesting the bus at the same time. The controller having the highest priority, it wins the arbitration process. Now all other controllers disconnect from the bus and wait for bus signal to become inactive, bus busy signal to become inactive again. So we have assumed that the controller 6 acts as an initiator that wants to communicate with controller 5. After arbitration process, controller 6 goes to the selection phase to identify the target. Now in selection phase, after winning the arbitration, controller 6 it will assert bus busy signal. So you can see here it will assert the bus busy signal after the process of selection. It will again assert the bus busy signal, and its address on the line DB6. So it will address on the line DB6. It indicates that it wants to select controller 5 by asserting a minus SCL select and minus DB5 lines. After placing the address of the target controller on the bus, the initiator it releases the bus busy line. Once the select line becomes active, other controller like controller 2 it stop driving the data line. So the selected target control responds by asserting a bus busy signal. This informs the initiator that the connections has been established. The initiator now it removes the address information from the data line and the target controller. will assert bus busy. After this, controller 5 has the control on the bus to proceed to the information transfer phase. Now, in information transfer phase, the information consists of command from the initiator to the target, status responses from the target to the initiator, and data being transferred to or from the input-output device. Target controller, it assumes the role of the bus master and uses handshake signals to control information transfer. The target, it asserts input-output signal during an input operation, that is target to initiator, and the -C bar D signal is indicated that the information being transferred is either a command or a status response. Now, high-speed SCSI bus uses a double-edge clocking to transfer data on both rising as well as falling edge of the clock, thus doubling the data transfer rate. At the end of transfer, the target controller releases the bus busy signal and the bus is free to be used to any other devices. It may re-establish the connection to the initiator controller when new data is available again. So this is done in the reselection phase. Now in reselection phase, after the information transfer is completed, the target suspends the logical connection with the initiator. When the target wants to restore the connection, it must gain control of the bus. So it starts an arbitration cycle, and after winning arbitration, it selects the initiator controller as described earlier. So, but now the initiator, it asserts bus busy signal before data transfer can begin. The initiator, it transfer controls to the target by making the target controller assert the bus busy signal. The initiator, it waits for some time to make sure that the target has asserted bus busy line and then releases the bus busy line. The connection between the two controllers is now re-established and the target is having the control of the bus. So let's summarize once so that we will remember it. So the thing is, the SCSI standard, it provides a mechanism needed to establish a logical connection and exchange messages between two controllers. The connection requires one initiator and one target controller because one has to send and another has to receive. Okay. The connection can be suspended and re-established at any time. The SCSI standard defines the structure and content of various types of packets that the controller exchanges to handle different situations. The initiator uses the packets to send the command it receives from the processor to the target. The target, it responds with status information and data transfer operation. So this function is controlled by the target. So in the next video we will learn about USB, that is Universal Serial Bus. So till then, please go through it. Lot of theory, I do understand. Please go through it taking your own time. So let me sign off now. Take care. Thank you.